Hello, my name is Todd Evans, and I am a Level 2 Product Support Engineer at Cole Morgan. And this video series is an introduction to the AKD Ethernet IP servo drive. Welcome to video 10 of the AKD Ethernet IP video series. In this video we will cover dynamic mapping. As covered previously in diagnostics, the command and response assemblies have built-in command status words and also some information like position and velocity feedback and the drive motion status. This is called the static map and is the default. The static map consists of bytes 0 through 35 in both the command and response assembly, and the data is passed every RPI scan as long as communications is established. The static map is not customizable. As noted in the data structure, bytes 36 through 63 are available for dynamic mapping. Dynamic mapping allows you to extend the information on the scan beyond the static built-in map. The mapping is done either in Workbench Terminal using the commands EIP.cmd.map or EIP.rspmap, or using the Workbench GUI under Communications, Ethernet IP, Command and Response tabs, which will be demonstrated shortly. Generally, the Workbench GUI is the most intuitive method. For example, under Communications, Ethernet IP, Response tab, you will find information and a button to configure what drive parameters you want to add to the response assembly. On the Response tab, you will find a list of mapped items, the free remaining bytes count, and the configure button. In this example, we will demonstrate adding both the current command il.cmd and current feedback il.fb to the dynamic map of the response assembly. When you press the configure button, it brings up the following window. You'll notice on the left they're beginning with ID or instance number 1. There's the parameter description or keyword, the type, and then the size, such as 2 bytes, 4 bytes, so forth. And then on the right there's the currently configured. You'll notice that at the moment nothing has been configured. In this example, we will look for the il.cmd in the list available on the left. Note there is also a search input that I will use to filter out the list by typing il.cmd. Instance ID 215 is shown to be the il.cmd, which is an integer in 4 byte size. Click on that row to highlight the instance or parameter you wish to select, and that will enable the right arrow key in the middle. On press of the right arrow key, the instance is moved from the left list to the right. Note below the currently configured list, the free remaining bytes have changed from 29 to 24 since 4 bytes were consumed by adding the il.cmd parameter to the mapping. Repeat the process to add il.fb to the currently configured list and click the Apply button first, then OK. The Response tab below now shows the configuration with the following columns from left to right. Address indicates which bytes in the dynamic region of the response assembly will contain the parameter data over Ethernet IP. ID indicates the instance number of the parameter. Parameter displays the parameter name. Type displays the parameter data type. Size indicates how many bytes the parameter data can contain. Value shows the value as displayed in Workbench, and EIP value shows the value over Ethernet IP. To correlate the address as shown in the Response tab with the address location of the data in the PLC, you have to look for the axis you declared in your tag database and its input or response assembly of 64 bytes. The sample project, the Axis internal, was named Axis 1 in the AKD drive add-on instruction. And in the controller tags under Axis 1 is axis1.input.data, as you can see below in the screenshot of the controller tag database. You can see that axis_1.input.data has been expanded out. In this example, axis_1.input.data and in brackets 0, which is the first byte of that group, correlates to byte 0 of the response assembly. From the response tab in the screenshot below, the dynamic map shows bytes 36 through 39 is equal to the il.cmd, and 40 through 43 is equivalent to the data of the il.fb. On the PLC tag side, you'll notice that I've highlighted in green the 4 bytes that's being from the axis_1.input.data 36 through 39 is going to contain the data as read when dynamic mapping is enabled, the data of the il.cmd parameter. And likewise, bytes 40 through 43 will contain the il.fb. However, it is important to note so far we have only mapped the data. In order to pass the dynamically mapped data every RPI scan, the map type in byte 33 of the command assembly has to be set to 2. If you look below per the AKD Ethernet IP Communications Manual, a snippet of the command assembly chart is shown. Highlighted in violet is byte 33, which is the map type, and you'll note that there are 3 possible values or selections. With the map type of 0, the static map, only bytes 0 to 35 are sent and received. With the map type of 2, bytes 36 through 63 are also sent and received in addition to the static map bytes. Note a map type 1 custom map is generally not used except for a specific customer and application, so this presentation will not go into details about it. In the screenshot below at the bottom of this slide, you'll see that there is a move block. It's unconditionally tied to the left rail. This unconditional move block is used to move a value of 2 into byte 33 of the command assembly output data of the axis called axis_1 in the sample project. This effectively turns on the passing of the cyclic data of the dynamically mapped parameters. 2 tags were declared in the controller tag database. Double ints are 4 bytes in this case, one for il.cmd and one for il.fb. If you look at the 2 rungs below, the COP or copy block is used to copy bytes 36 through 39 into AX1_il_cmd, and another to copy bytes 40 through 43 into AX1_il_fb tags. Note the chart below indicates possible data sizes of AKD instances and the equivalent data type of a tag declared in the PLC. In this way, the length is 1 for the destination tag, since the destination tag is declared to contain the same data size type as the parameter that is dynamically mapped. During runtime, you can compare Workbench with a quick watch in RSLogix 5000. The values of the screen capture are scan dependent, but you can see the values closely match. It is important to realize that the EIP value, for example 0.148, or around 0.150 in Workbench, is displayed in the PLC in the watch window as a times 1000. It's an integer value. Now I'm going to demonstrate how to add this functionality to the PLC project and the drive. From the Communication, Ethernet IP, and the Response tab, you'll notice that nothing has been configured at this point for dynamic mapping. So I'm going to click the Configure button. I'm going to type il.cmd, magnifying glass. There it is. I'm going to click the right arrow key, it configures it. I want one more in this example, the current feedback. That adds it as well. 4 byte signed of each. Apply, okay. It adds it to the list. Right now the data is not actually being passed to the PLC. As far as the drive configuration, this is really all we have to do. I'm going to click Save to Device so that it saves the setup to non-volatile memory. And I'm going to go to the PLC. I'm going to add a rung here, and then I want to add a move instruction. I want to move a value of 2 into, in this case, axis 1 dot output dot data, and then brackets 33. Enter. So this is going to move a 2 into the map type for axis 1. It will turn on the data being passed for dynamic mapping. Okay, so I've added 2 rungs, and then for each rung I want to add an unconditional copy instruction, COP. Next I want to create a tag for the destination. So I right click, new tag, and give it a name. In this case I'm going to use AX1 underscore IL underscore CMD underscore value, and it's going to be set as a double integer because that's the same as the data type for the instance. Create. I'm going to do the same thing for the next copy instruction. I'm going to do a new tag, AX1 underscore IL underscore FB underscore value. It also is a double integer, so I create it. The length in this case will be 1 because we're going to move the same amount of data as what the destination is declared as, which is 4 bytes or double integer. Recall that the starting address for each one is 36 and 40 per the dynamic mapping on the response tab in Workbench. So moving back, the source is going to be, in this case, axis underscore 1 dot input dot data, and then in brackets 36. The next one's going to be axis underscore 1 dot input dot data and 40. So we're all set. So the only thing we need to do now is save it, and then we're going to go and we're going to download the changes to the ladder to the PLC. Okay, it's complete. We're going to change back to run mode. Okay, after downloading, I need to re-enable my drive with the AKD enable add-on instruction. And if I wanted to just monitor the values online, I could hover my mouse over the given tag and you could see the value change. For example, but in this case I want to do something that's a little bit easier to monitor it with, so I'm going to use a quick watch, and I'm going to do axis, that one. So now I can more easily monitor the values. All right. I could also use the watch window here if I wanted to, or I can just jump to current loop, for example. See these values here, or since these are dynamically mapped, I could also go to and look and see the Ethernet IP value and compare that to this. And so if I load this up, you can see that the EIP value if I relax it a little bit, you can see it's roughly the EIP value times 1,000 in the quick watch of RS Logix 5000. So this is how you do dynamic mapping